Chapter 12. Some Natural Phenomena. Introduction. You already know about some natural phenomena, such as winds, storms, and cyclones. They destroy both property and human lives. This chapter will cover two additional natural occurrences, lightning and earthquakes, and how to safeguard ourselves from them. Lightning. Since the creation of the universe, lightning has existed. In the past, people believed that lightning was how gods expressed their wrath. Lightning is now understood to be nothing more than electricity. Learn more about static electricity and electric sparks before learning more about lightning. Static electricity. The discovery that amber attracts light objects when it is rubbed on animal fur is credited to the Greek mathematician Thales, who is credited with discovering electricity in 600 BCE. It was believed that he observed the amber static electricity generated by rubbing. Early in the 18th century, numerous electrical experiments were conducted, leading to the development of static electric generators. What is static electricity exactly? Let's try out some exercises to better comprehend the origins of static electricity. The static charge in an object can be detected by a device called electroscopy. Let us make our own electroscope and see how it works. Can you think of a variation in this experiment to create attraction between the strips? In the above experiment, you touch the aluminium strips with hand after they repel each other, and they will come back to their original position. This is because the charge present in the strips transfers to the earth through your body. The strips are now said to be discharged. The process of transferring the charge from a charged object to the earth through conduction is called earthing. All electrical gadgets we use are provided with earthing to protect us from electrical shocks. What causes static charge to form? The previous chapters taught us that matter is composed of atoms, which are incredibly tiny things. Despite being neutral, these atoms hold smaller, charged particles. Protons are positive particles that are located in the nucleus, the center section of an atom. The electrons surround the nucleus and are negative in charge. Electrons are bonded to atoms either strongly or loosely depending on the substance. Electrons may move from one surface to the other when two objects are rubbed against one another. Loosely bound electrons are transmitted to the other object when two object surfaces are rubbed together. This causes an object to become positively charged when it loses electrons and negatively charged when it gains electrons. We refer to these costs as static charges. As a result, an object acquires negative charge when it gains electrons and loses electrons when it gains them. These expenses are known as static charges. The following methods can be used to produce static electricity. 1. By rubbing two things' surfaces together, one becomes positive and the other becomes negative. 2. When an object is in contact with a charged body, the object will acquire the same charge as the charged body once the charge from the charged body transfers to it. 3. By approaching a neutral item with a charged body close to it without making contact, the charged body attracts the neutral item. Paper fragments stick to the rubbed scale for this reason. The charge on the scale is negative. The portion of the paper closest to the scale grows positive as we approach it, and the paper adheres to the scale. This is also the cause of earthly lightning strikes. Electric spark. You must have noticed electric sparks During the winter, when removing an acrylic sweater from your body, two items with opposite charges generate an electric spark. One becomes positively charged and the other negatively charged when two things are rubbed together. When a lot of positive and negative charges cluster together close to one another, the air between them becomes heated. For a little moment, the air illuminates and makes noise. The air loses its ability to insulate. During this time, allowing one charge to go to the other, we refer to this audible air glow as an electric spark because the two charges cancel each other out and become neutral as soon as they come into contact. It only lasts for a brief period of time. Thus, the transfer of charge between two surfaces through air results in an electric spark which generates heat, light, and sound. Lightning is a very large-scale electric spark. The story of lightning. The first person to demonstrate that clouds accumulate charge during lightning was Benjamin Franklin. He secured a metal key with a silk kite thread. In 1752, he flew the kite above the clouds during a thunderstorm. After some time, the key was struck by lightning, making it hot. When he touched the key, which had become electrically charged as a result of being struck by lightning, he experienced a little electric shock. He came to the conclusion that the same mechanism underlies both lightning and little sparks produced in our clothing. Now that we know how lightning happens, on a stormy night, the air currents rise higher as a thunderstorm forms, while the water droplets flow downward. Positive and negative charges are separated from one another as a result of this ferocious action. Clouds' top sections tend to acquire positive charges, while their lower regions tend to amass negative charges. As a result, the induction process also causes positive charges to build on the ground. Because it is an insulator, air cannot withstand an increase in the magnitude of charges. A brilliant flash of light and sound are produced when the negative and positive charges collide on the earth. Lightning is this burst of brilliant light, and the phenomenon is known as an electric discharge. Between two clouds with dissimilar charges or between clouds and the earth, an electric discharge might happen. Safety during lightning. During a thunderstorm, lightning can strike anywhere at any moment. It is unsafe to be outside during a thunderstorm. When you hear thunder, you should immediately seek shelter. Depending on how strongly the charges interact, lightning can either completely destroy a building or a tree it strikes. There are presented the numerous safety precautions that must be taken during lightning. Outside the house. 1. Avoid standing close to or under trees. 2. Don't hang around in a public area. Take cover inside a structure or, if you're in a forest, hide under some short trees. 3. Keep clear of poles, towering trees, and metal things. 4. Unsecured vehicles, such as motorcycles, tractors, open cars, or machinery, are dangerous. 5. If you are in an open place, avoid lying flat on the ground. Instead, crouch down. This lessens the likelihood that an electric current may flow through you and to the earth. 6. Keep away from bodies of water, such as lakes, ponds, rivers, and swimming pools, as they are good conductors of electricity. 7. Avoid opening an umbrella when it's storming. Inside the house. 1. Prevent using electronic devices like computers and televisions when lightning is present. Shut off all electrical devices. 2. Avoid using a corded phone. Instead, make use of cordless or mobile phones. 3. Keep windows and doors closed and stay away from them. 4. During a thunderstorm, avoid using the bathroom or coming into contact with metal taps or running water. Lightning conductor. Both life and property might be at risk from lightning. A tall building can be shielded from the devastating effects of lightning by using a lightning conductor. A metal rod with spikes on top and a copper plate attached at the lower end, which is buried in the ground, make up the device. A little bit taller than the structure is the metal rod. Therefore, if lightning strikes, the electric discharge travels through the metal rod and directly to the earth without endangering the structure. As a result, the metal rod offers a simple pathway for the movement of charges into the ground. Earthquakes. In our lifetimes, we all experience an earthquake. For that terrifying brief period, the ground beneath our feet and everything around us begin to tremble. Earthquakes are a type of natural disaster that strikes suddenly and can seriously harm both people and property. Let's examine the definition and origin of an earthquake. Structure of the earth. Standing on the ground, you must think that the earth below your feet is solid and hard. It does not undergo change. However, this is not true. Our earth is made up of different layers which keep changing. The earth has a radius of about 6,375 kilometers, and it is divided into the following parts. Core. It is thought that iron and nickel make up the majority of the earth's core. The core's deepest region is solid. The liquid that makes up the core's exterior is constantly in motion. It is thought that the Earth's magnetic field is caused by the movement of this core. Mantle. It is the thick layer above the core. It is made of dense and hot rocks. The inner part of the mantle is partly liquid and is called magma. When the magma comes out of the earth, it is called lava. Crust. It is the outermost layer of the earth on which we live. The crust is thicker on the continents but thinner under the oceans. The crusts along with the upper part of the mantle are together called the lithosphere. Movement of continents. Crust is a thin layer on the surface of the earth. It is made up of different pieces called plates. These plates float slowly over the mantle like a raft moves on water. Note that the plates move very, very slowly, about 1 centimeter per year, so their movements are not detected. Occurrence of earthquakes. The Earth's crust's movable plates pass one another. There is friction between them as they come into touch, which could prevent them from moving. Rocks on the margins of two plates can occasionally lock together. This results in the development of the forces. The plates jerk past one another when the forces are quite severe. This causes enormous waves of energy to be released. Earthquakes are brought about by these waves shaking the crust. The place from where the vibrations originate is called the focus of the earthquake, and the point vertically above it on the surface of the earth is called the epicenter. The energy waves that originate from the focus are called seismic waves. When these waves reach the surface, they cause the surface to shake and crack. This may lead to sinking of ground and falling of all construction on the surface. The energy released by big earthquakes is tremendous. It is equivalent to energy produced by many atomic bombs. This is the reason earthquakes cause so much damage. Not all earthquakes are caused by colliding plates. Sometimes an earthquake is caused because of eruption of a volcano. A nuclear explosion carried underground can also cause an earthquake. Measuring intensity of earthquakes. The Richter scale is the scale used to measure an earthquake's intensity. Charles Francis Richter, a seismologist from the US, created it in 1935. On this scale, the intensity of an earthquake is measured from 0 to 9. Earthquakes till the magnitude 3 on the Richter scale are not felt by us. They happen very often but are not a cause of worry. Up to the magnitude of 5.5, an earthquake can move objects and sway buildings. At higher magnitude, the earthquakes become dangerous and can damage buildings and infrastructure. An earthquake of magnitude 8 or more can be very dangerous. It can wipe out entire cities. Earthquakes of high magnitudes can deform the ground surface. They can cause landslides and change the course of rivers. Sometimes, they cause the oil and gas pipelines to rupture, which can cause huge fires. Sometimes earthquakes also cause tidal waves or tsunamis. An earthquake with focus in the ocean sends out waves at very high speed. When these waves reach near the shore, they slow down. As a result, they rise very high. A tsunami wave can go up to a height of 30 to 40 meters. These waves crash into the coastal areas and cause huge damage to life and property. Earthquake-prone regions, the regions which are near the plate boundaries, are more prone to earthquakes. These are called seismic zones or fault zones. In India, Kashmir, Northeast region, Western and Central Himalayan region, Rajasthan, the Rann of Kutch and the Indo-Gangetic Plains are the areas in the fault zone. Protection against earthquakes. Earthquakes cannot be foreseen. They are capable of becoming extremely destructive, as we have seen. Therefore, it is crucial that we always take the required safety steps to keep ourselves safe. Residents of seismic zones, where earthquakes are more likely to occur, must take extra precautions. The first thing is that the structures in these areas need to be built to withstand significant earthquakes. It is feasible thanks to modern construction technologies. Making the building straightforward will make it quake-safe. 1. Speak with experienced structural engineers and architects. 2. Mud or lumber are preferable to heavier building materials in seismically active places. Roofs should be as light as possible. The damage won't be severe if the structure falls. 3. To prevent accidental falls, it is preferable to attach the shelves and cabinets to the walls. 4. Be careful where you put wall clocks, picture frames, water heaters, etc. to prevent people from being hurt if there is an earthquake. 5. All buildings, especially tall buildings, must have firefighting equipment that is in good working order since some buildings could catch fire as a result of an earthquake. Building expertise for quake-resistant homes has been created by the Central Building Research Institute in Roorkee. Take the following precautions to safeguard yourself if an earthquake does occur. 1. If you are at home, take cover under a table and wait there until the shaking stops. Steer clear of heavy, high objects that could fall on you. Stay in bed if you're already there. Pillow your head to provide protection. 2. If you are outdoors, locate a clear area away from structures, trees, and overhead power lines if you are outside. Get down on the ground. Refrain from exiting a vehicle, whether a bus or car. Tell the motorist to take it easy and find a space to park. Wait till the earthquakes end before leaving. In a nutshell, when two objects are rubbed against each other, one of them becomes positively charged and the other becomes negatively charged. Static charge is the accumulated charge in a body. This charge does not transfer. Static charge can be measured with the help of a device called electroscope. Transfer of charge from a charged body to the earth is called earthing. A spark is created when opposite charges accumulate close to each other and the air between them heats up and starts glowing. Lightning is a big electric spark created between the clouds and the earth. A lightning rod protects from lightning by transferring the charge coming from clouds to the ground. An earthquake is the sudden shaking of the earth's crust when its plates rub past each other. An earthquake is measured on the Richter scale. The point on the surface of earth below which the earthquake originates is called its epicenter. Earthquakes can cause destruction of property and life, landslides and tsunamis.